Hi, this is Chris, and we are finishing up the multiple choice here in section 3 of SAT Practice Test 3. So for question 13, they give us this really long and complex looking equation. And the question is asking, what is the value of A? So when you do long division of polynomials, and I'll put maybe an example down here. So let's say we had something like x minus 2, and it's being divided into, let's say, something like 3x squared plus 5x minus 17. So you're going to go just one term at a time. You're going to look at the leading term of each expression, and you're going to say, okay, if I were dividing 3x squared by x, then what would I get as my result? So although it looks like it's, a very long, complex polynomial, we can actually evaluate this just one tiny little piece at a time. And that tiny little piece is going to be leading terms. And so here, 3x squared divided by x, one of the x's on top would cancel out with the x on bottom, and we're left with 3x. So you would put 3x here, and then to figure out what goes next, right, we'll have plus sort of question mark there, plus dot dot dot. So here, the rest of the terms are going to be determined by distributing out that 3x to each of these, and then putting that expression down here, subtracting it, and changing the sign of each, and canceling, and so forth and so on. The question is going to be a lot lengthier than that, but what we want to really appreciate and take away from this is that we don't have to worry about any of that part of it, because all we care about, in order for us to have enough info to get to a correct answer for most of these polynomial long division questions, is just what that relationship between the leading terms and the corresponding quotient would be. So let's see if we can apply this concept of focusing just on those leading terms to this question. And here, we take a look at this complex looking relationship, but we're going to look just at these leading terms and the corresponding quotient, just those three pieces. And let's see if we can simplify this and solve for A much more easily than what this question originally suggests with its level of complexity. Here we have 24 x squared divided by 8x. And again, right now all we care about are those leading terms, and the leading term in that quotient would be negative 8x. And let's see if we can simplify accordingly. So one of those x's cancels out with that one. We're left with 24x over a equals negative 8x. We can actually cancel these two x's and multiply both sides by a to get 24 equals negative 8a. Divide by negative 8, and we get a equals negative 3, which is our correct answer here. So remember, when dealing with division of polynomials, think leading terms. And that should be enough for most SAT caliber questions, even some of the highest level difficulty questions. That should be enough for us to arrive at a correct answer. Up next, we'll take a look at 14. And here we're dealing with another polynomial, but this one's going to operate a little bit differently. They want solutions to this trinomial that is set equal to 0. And let's see if we can simplify this a little bit. Because, again, first glance, that looks complicated. But if we notice, each of these terms is divisible by 3. So if we factor out a 3, divide everything by 3, we're left with x squared plus 4x plus 2. So that's a great step in the right direction, because we're already so much closer to something a little easier on the eyes, if nothing else, and certainly something a little bit more manageable calculation-wise. But if we look at this and we think to ourselves, well, let me see if I can factor this out. Unfortunately, this is not going to factor out very easily. So when we go to do that, we might say, not too sure how I would factor that out. Let's try something else. So what's another way that we could find potential solutions if we have an equation that is difficult to factor, well, we can use quadratic formula. And quadratic formula we should know, and they're not going to give it to us at the beginning of the math section. They do offer a couple helpful formulas, but that's not one of them. So that we just have to memorize, and I'll put it down here. It's worth making a quick flashcard of, or adding to a Quizlet or whatever you want. But you get negative b plus or minus the square root of b squared minus 4ac all over 2a. And so if that's something that you don't already know, if you're going to tackle a question like this, that means we just have to make it a priority to memorize that. So now let's figure out what those a, b's, and c's mean in reference to our equation. It's just the coefficient that we have on each term. A is the coefficient on your x squared, b is the coefficient on your x, and c is your constant. So here we would have an a of 1, a b of 4, and a c of 2, and we just have to plug it into that quadratic formula. So this would be negative 4 plus or minus the square root of 4 squared minus 4 times a times c all over 2 times a. And then from here, we need to simplify as much as we can. So this will be negative 4 plus or minus the square root of, that's going to be 16 minus 8, so it's just square root of 8 over 2. And square root of 8 can be rewritten, let me make that square root sign a little bit more appropriate to size, but that can be rewritten as 2 root 2. Here, when you go to break down the square root of 8, let's see, let me put that in down here, but that's the same as saying the square root of 4 times the square root of 2, and the square root of 4, hopefully we know, is 2. So that's where we get 2 root 2 as the simplified form of root 8. And so here we have plus or minus 2 root 2. And the whole thing is divided by 2, which means we can divide each term in our numerator. Negative 4 divided by 2 is negative 2, and 2 divided by 2 is 1. So this will simplify to negative 2 plus or minus the square root of 2, which is going to be answer choice A. So again, first instinct, anytime you have an equation, if you have a factor in common to every term that you see, you can always factor that out or divide by that value in order to simplify. And then the second content piece of this is we just have to know quadratic formula. And if we have that in our toolbox, then it makes a question like this something that we can tackle. If we don't, unfortunately, this might be a question where we have to guess and move on. Up next, we'll take a look at 15. So this is our last question in the multiple choice, and they give us an equation here. And they tell us the equation above shows how a temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. So this is an equation basically that allows us to convert from Celsius to Fahrenheit or Fahrenheit to Celsius. Based on the equation, which of the following must be true? Temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Temperature increase of 1 degree Celsius is equivalent to temperature increase of 1.8 degrees Fahrenheit, and a temperature increase of 5/9 degrees Fahrenheit is equivalent to a temperature increase of 1 degree Celsius. Well, from a strategy perspective, if we look, we can see here that for Roman numeral 1 and Roman numeral 3, they've really just switched around the relationship. So basically they're saying, is Celsius 5/9 Fahrenheit, or is Fahrenheit going to be 5/9 Celsius? That's what those two are saying. So they oppose each other. So here, let's see what that relationship is going to be. Which one goes up 1 when the other one goes up 5/9, and vice versa. And here, if you were to distribute that 5/9 that you see in the equation given, so this would be the equivalent of saying that Celsius is equal to 5/9 Fahrenheit, and then minus, and if you multiplied that out, that would give you 160 over 9 as an improper fraction. I'll tell you a helpful little trick here is that when you're looking for this relationship about how one value is impacted by another, all we really care about is going to be this relationship here. The constant is not going to tell us anything about how Celsius changes with an increase in Fahrenheit or vice versa. That relationship will only be determined by this portion of the equation right here. Think of it as if your coefficient is acting as your slope, because this is really just different variables but expressing the same type of concept as y equals mx plus b. That slope is going to tell you how one reacts to the other value, or how one value impacts the other value. And here, whenever you plug in a 1 for Fahrenheit, because you're multiplying it times 5/9, you would get 5/9 as your change for Celsius. So let's see whether it's Roman numeral 1 or 3 that matches this relationship here, with Celsius changing 5/9 for every 1 degree change in Fahrenheit. And if we take a look, this says 1 degree for Fahrenheit corresponds to 5/9 Celsius. And if we look, that's exactly what we see depicted here. So this 1 degree Fahrenheit for every 5/9 Celsius matches this numerical relationship right here. We're going to say yes to Roman numeral 1, and since Roman numeral 3 is the opposite, I'm going to say no thanks to Roman numeral 3. And let's see how that impacts our answer choices. Because again, with Roman numeral questions, sometimes if you can come up with an answer to even one of the Roman numerals, then you can at least eliminate a few answer choices. And here, by saying yes to Roman numeral 1, that means that we can eliminate answer choices B and C. So even if we had to guess from there, we'd still be 50-50 on this question, which isn't bad for the toughest multiple choice that they're going to throw at us. Now let's check out Roman numeral 2, because this one's a little bit interesting. They have this number in here of 1.8, and at first glance, it might seem like this has nothing to do with anything going on in the question. And I hear that from students a lot. But it's really important to understand where that comes from. And sometimes there is an element of having really strong mental math skills to allow you to, quote unquote, see a question in a certain way. Because here, 1.8 is actually, as a fraction, that's going to be 9/5. That's where the 1.8 comes from. It's really just the reciprocal of that coefficient that they gave us in our equation at the top. So let's see how that relationship might hold up. C is equal to 5/9 F. We already said that when we were able to draw that conclusion up here. Well, let's check out the reciprocal. If you multiplied by the reciprocal, you would have 9/5 C equals F. Or another way of saying that is 1.8 C equals F. And here, using the same logic that we used before, we could say, well, a change in Celsius of 1 degree is going to correspond to a change in Fahrenheit of 1.8 degrees when we have to multiply it by that coefficient. So if you plugged in a 1 for C, you'd get 1.8 for F. Now let's see how that relates to Roman numeral 2. 1 degree Celsius is going to correspond to a change of 1.8 Fahrenheit. Does that match what we see here in this relationship? It sure does. And our correct answer is going to be answer choice D, that it's Roman numerals 1 and 2. So this is certainly a very tough, very complicated question, but our takeaway here is that even on, in theory, the toughest multiple choice, if we understand at least this numerical relationship that we highlighted in here and ignore our constant, it can make it a little bit easier for us to hopefully identify the correct relationships between Celsius and Fahrenheit, or C and F, in an equation like this. Up next, we're going to